What you see here is a Sketchfab model, one of the most useful architectural and BIM tools available in any market. And these allow tradesmen, the clientele, superintendents, everyone to stay on the same page and have one model to refer to for discussions and decisions. Now, almost every framing member is included in these, and they're very easy to use. Just by double-clicking on any area or object, you can orbit that object as close or as far away as you'd like. You can see the drywall and OSB hatches on both sides of the wall. And for clarity, the OSB sheathing over the floor has been excluded. This is a very advanced software that is available on the web, so any internet-connected device can access this. Smartphones, tablets, regular computers. No matter which device you have, it will be able to run this because it is an easy-to-run software that doesn't take up a lot of space on any device. So the approach that we have here, this model-based approach, is dependent upon that software, and it ends up meaning that we have a higher quality product at a lower price with less mistakes. Now, the architectural software we use to create the floor plans themselves are what we use to export these models here, so they are exactly the same as what is depicted in the 2D plans. Now, for trusses, for instance, we will take the PDF supplied to you by the truss designer and then put those trusses onto the house using its top plates and beams, as you see here, to audit that set to make sure that there aren't any problems. And to date, we haven't had any go through that didn't have some problems that we needed to amend. An example of that, for instance, is here, where the truss designer did not account for the chimney. There are other numerous violations of the design intent here that we were only able to catch in 3D because of the clarity that you see. For instance, this line here was meant to be maintained when it was not. Now, as we go through these models, one of the other important things to remember is that all of these members, no matter which member it is, we have automatic takeoff capabilities in that the software will simply tell us how many of each were used to build the structure. All of these are individual components, and they all exist independently within the software, which means the scheduling tools can account for all of them and give us even cut sheets. With a bit of work, then even cut sheets can come out of those for production work. Now, the detailed versions of these that we can make will include nearly every piece of information you could ask for in there. So here we have framing diagrams, individually labeled components, takeoff information put directly into the plan, as well as the dimensions that you would see on the 2D plans that you would be reviewing at the same time. You can see that wall sections appear directly in 3D, as does almost every other member that is relevant to that plan. As you can see with this one, the foundation and all of the other members are visible and easy to review. Now, there are 2D sections, of course, that come with each of the plans, and you can closely review these while you're looking at the 3D model, and it answers any questions that really you may have. For instance, framing elevations such as this one, or sections. So it contains a great deal of information that will help the framers to stay out of trouble because it answers whatever questions may come up while they're in the field. And in the case that it doesn't, it will be easy to infer because of the amount of information about everything else around it, even individual treads. Now, we can produce that to a lower level of detail or a higher level. The important part is that we make sure to depend on the 3D model that ties them all together and make sure that they're all correct. Now, we draft these using a task group approach so that it's very efficient, and that efficiency has allowed us to offer a price that is not higher than a conventional method of architecture, but produces the result you see, and that saves you time, money, and stress during the entire life of the project because you'll have takeoffs that are dependable. You would have sections and other engineering materials that you could actually use in the field because you can know that the information is correct. It wasn't pulled out of anywhere. It wasn't calculated. These are all measurements that are taken. These are reported values about the structure that are set in stone because we have a real 3D model to reference. That is a large difference from conventional architecture, and with our efficient approach and the tools we've developed, we're able to do that less expensive than a conventional method because we make sure, and adhere to our principles and keep all of the variables in check. In any event, thank you very much.